So, why did data engineering becomes its own discipline? Have you ever looked into that? I've always been curious about what led to the creation of something, like what problem was something created to solve. So, imagine this. It is Black Friday for a major e-commerce website. The production database, which likely is a PostgreSQL or MySQL database, is optimized for online transaction processing. Its job is to handle thousands of small, fast transactions per second, like add to cart, update inventory, and process payment. This workload requires high-speed data writes and row-level database locking to ensure two people don't buy the last product in inventory at the same time. Now, it's midday, and the CEO demands a real-time report on total revenue by region to make a marketing decision. So, a data analyst connects directly to the production database and runs a massive aggregation query like this. This query forces the database to scan millions of historical rows of data. The database CPU spikes to 100% as it tries to read the entire history of the table. Because the database has finite resources for input, output, memory, and CPU, it physically cannot process the incoming checkout requests anymore. As a result, the checkout page freezes for customer trying to pay, and the site effectively goes down. So, the business just lost millions of dollars because of a single database query. This failure reveals the fundamental problem. Operational databases are optimized for index seeks, meaning finding one specific record very quickly. However, analytic queries often perform full table scans, meaning they must read every single row in the database to aggregate a result. The hard drive disk has a maximum limit on how much data it can read or write per second. A single analytical query reading terabytes of records can consume 100% of this bandwidth. Another problem is the locking mechanism used by database for concurrency control to ensure data is never corrupted when two people are trying to access the same record. To calculate an accurate report, an analytical query often places a read lock on the whole table to prevent data from changing while it counts. This read lock does not prevent others from reading the data, but it does prevent everyone from writing to the data, which is what happens in this example. All incoming write transactions are blocked until the lock is released. So, do you see the problem here? We need a way to separate these two workloads while ensuring data integrity and consistency. This is why we need data engineers. Someone needs to create a copy of the data so the analyst can run their heavy report without crashing the store. It sounds simple, but trust me when I say that this is not a copy and paste problem. There are a lot to consider, and it requires a lot of assessment and planning to make sure that we can maintain data integrity. To understand why the database crashed when the data analyst tried to run that massive data aggregation query, we must look at the hard drive. Hard drives do not read rows or columns, they read blocks of data, usually in 4 kilobytes or 8 kilobytes chunks of data. The production database in our example uses row-oriented storage, which is very common for operational databases because it's designed to optimize transactional update speed. To understand row-oriented storage, we need to look at how computers store data on a hard drive or in RAM as a linear sequence of bytes. A row in this context represents a single record of customer order with ID, item, and sales columns. To understand the rest of this explanation, we need to distinguish the difference between the logical representation of the data and the actual physical representation of it when stored on a hard drive. The hard drive doesn't have a grid, which most of us are often trapped in when visualizing a data table as something like this. However, as much as our human brains love 2D grids with rows and columns, storage medium like magnetic tape or hard drive are fundamentally linear tracks. Think one-dimensional instead of two. Imagine our table as a single, long stream of text. So the above table would look something like this when stored on the hard drive. If we need to find the total sales, the database has to read every single row, including the ID and item, just to get to the sale number at the end. To solve this, we store data in columns instead of rows. This is known as column-oriented storage as compared to the row-oriented storage used in operational database we mentioned earlier. That way, all the sales numbers are stored together in one block. So when we query for the total sales, the database ignores the ID and item and goes straight to the sales block and adds it up, making it lightning fast for analytics. Therefore, data engineering is about setting up an automated system that moves data from row-oriented to column-oriented to optimize data analytics and leave operational database unaffected. Remember our Black Friday disaster? So, what does the data engineer actually do to save the company? They would create a separate copy of the data in a data warehouse like Snowflake or BigQuery. So, every night we automatically extract the data from the operational database or the source, transform it, and load it into the data warehouse. Instead of querying the source database, we would query the data warehouse instead. So, now that we understand what problems data engineers are here to solve, how were these problems solved before data engineers came into the picture? We will cover that in the next video.